this one, which is having more energy, beta? Reactant is having what? More energy. With products are having what? Less energy. Now, definitely if you substitute the things here, delta H will be negative only. Now here, reactant will reach transition state, threshold energy. This is called threshold energy. Threshold energy, we can call this one. After that, reaching this maximum state, it will convert into products. There you are getting less energy here. So this is the activation energy. Generally, the reactants to convert into products, the amount of energy it should reach, that is called what? Activation energy. After that, what happen? It will give the product. For example, a molecule is there, nitrogen is there. Nitrogen will go to what? Threshold energy. Then this will convert into, for example, 100 molecules are there. Out of 100 molecules, only 70 molecules can reach here. They convert into products. If the remaining 30, they can't reach here, they could not convert into products like this. Now, endothermic reaction, heat is absorbing in this case. When heat absorbs in a chemical reaction, then they are called endothermic reactions or endoergic reactions. Now, the same reaction, I will take nitrogen with oxygen here to give nitric oxide. Here heat is evolving. You see minus. If you send this one, what happens? It becomes less H. This endothermic reaction. In this case, products are having more energy when you compare with reactants here. Therefore, delta H will become here what? Positive. Here, delta H is what? Positive. Understood better. When it comes to what graphical representation, what happened? See, products are having what? More energy when you compare with reactant. Reactant is having less energy. Product is having more. This is the energy value. This way, we can get this. Can you give the answer for this one? In exothermic process, heat is given out or given out. Given out or taken out. Definitely what happened? Given out.
Given out.
Delta H positive for which reaction, beta?
And endothermic.
Endothermic.
Now, if I write some reaction like this, beta, I am writing some reaction over here. Now, can you say what type of reaction it is? What type of reaction it is?
Exothermic.
Exothermic only. Why? Because if this minus heat, if you send here, it becomes here plus heat. Plus heat means heat is releasing. Exothermic reaction. Understood better? By seeing the heat, you can't say minus heat. Send this minus heat over to product side. Minus becomes here what? Plus. Now heat is releasing. Exothermic reaction. Understood? For example, if I write what happened, calcium oxide, same thing I am writing to avoid the confusion. I am writing same thing here. Calcium carbonate. I am writing here minus heat. Minus. For example, if I write minus heat, what happens? Which reaction it will be?
Endothermic.
Now, if this minus comes here, what happened? Plus heat. Now it becomes like calcium oxide, carbon dioxide plus heat is giving what? Calcium. That means what happened? Heat is what happened here? Absorbing here. Correct? So you may get like this also in questions what happened. By putting what happened, heat like this. Okay, you can easily, by sending that heat into what? Left hand and right hand side, you can easily identify that. How you measure delta U values here? How to get that internal energy values here? So measurement of internal energy or enthalpy can be done by calorimeter. The heat evolved in this process can be determined by the temperature change. By temperature changes, we can calculate the heat evolved in the process. Measures can be taken in two conditions. One is at constant pressure, other is what happened? Constant value. By using constant value and constant pressure, we can measure the temperature so that what happened? we can get the heat actually. Delta U measurements, if you observe, absorption of heat at constant volume can be measured in bomb kilometer. That means at constant volume, heat can be measured by using bomb calorimeter. The energy changes associated with reactions are measured with no work done under constant volume. So when you're doing what constant volume, work done will be 0 because W is equal to what here? P into delta V, then delta V equal to 0, isn't it? Delta, because if you take constant pressure, what happened? Delta V becomes 0 bit, correct or not? Delta V is equal to what? V final minus V initial. And both are same. If it is 50, if this is also 50, because we are not changing the volume here, correct? Then it becomes 0 here. So work will be 0 in this case. So whenever you are doing constant volume, the work done will be 0, correct? Now this is the bomb calorimeter beta. Okay, the diagram of the bomb calorimeter, isn't it? So various operators are taken in this case. I have taken water inside. I put that bomb in this case and a sample. Then whatever the sample, it may be food or anything, you can place over here. For agitation, you are taken stirrer here for stirring this one, and for putting that pressure, you are taken oxygen. Combustion reaction, okay, because you are burning, no, bomb will burst, it will burn. For burning, what is the help we need? Oxygen. In the presence of oxygen, combustion will take place. So I have sent this oxygen at high pressure over here, and firing lets to get the fire, isn't it? You get the, then when the fire gets, what happens? Bomb will explode, then it will burn actually. So firing lets we have taken, and to measure the temperature when heat is releasing, no, to measure the temperature, the temperature we are measuring by using thermometer that I put in the water actually. So this is actually the operators we are using for measuring the internal energy. And if you know the internal energy, we can calculate the delta H by using which formula beta? Delta H is equal to delta S plus delta N into R. Already formula is there. So when you calculate delta U here, you can easily calculate delta H by using this formula. Now here heat combustion, the heat is equal to Z into theta into M by capital M by small m. Capital M, small m is equal to what actually I will explain you. Z is equal to heat capacity of calorimeter and water. Already you know heat capacity of calorimeter means amount of heat is required to raise the temperature by 1 degree Celsius. So this for calorimeter beta. This will be constant because this is a calor for instrument actually. And how much temperature increased here? That is what theta value. M is what? Molar mass actually. Mass here, this one. Mass in terms of grams. Where M is what? Molar mass. Capital M is what? Molar mass, this one. For example, if you take what something, what happened? Methane if you take, molar mass will be 16 lakh. Glucose if you take, molar mass will be 180 lakh. Can you give the answer for this one? Absorption of heat at constant value can be measured in? Formula, can you say the formula here? Which formula you are taking? This formula, correct or not? Z into theta into?
No, sir.
Z into theta into M by M. This is what? Molar mass. This one is weight. This one is how much temperature is raised. If it is 2 degrees, 3 degrees, this one is the constant value of what? Calorimeter. Heat capacity of calorimeter. Delta H, how you calculate? You got delta U now here. By using this formula, we are calculating delta U. Why? What is the difference between delta U, delta H difference? Do you know the difference between delta U and delta H? Internal energy, right? This one is enthalpy. What is the difference between these two? This is the enthalpy. This is the enthalpy at constant volume beta. At what? Constant value. This is the enthalpy at what? Constant pressure. Constant pressure. Delta P. Enthalpy at constant pressure is called what? Delta H. Enthalpy at constant volume is called what? Internal energy. Understood better? Now I have taken constant volume, therefore the heat here nothing but delta U. Enthalpy delta H can be calculated at constant pressure. Delta H is nothing but at constant pressure. Okay. Now delta H is equal to here what? QP also I can write. Delta U I can write what? QB. Heat at constant volume is delta U. Heat at constant pressure, delta H. The heat absorbed or evolved at constant pressure is called what? Enthalpy of reaction, delta. Now, most of the cases, the chemical reactions carried out in constant pressure only. Therefore, whenever if I write enthalpy, I will write delta H only. We don't write delta U because we'll take at constant pressure. In an exothermic reaction, heat is evolved, then QP will be negative. See, in exothermic, definitely what happened? Delta H will be negative, and QP, heat also will be negative. For endothermic, Q will be positive, delta H will be positive. It's already you know these two things. Taken a foamed polystyrene cup. Here I have taken reaction mixture inside. I have taken thermometer now. Now by using this one, we can easily calculate the change by measuring the change in the temperature. We can calculate the enthalpy of reaction. Because already I told you, no, heat is equal to what is the formula beta? C into what? Delta T. Now you substitute delta T value here. Definitely we are going to get these values here. Because this heat capacity you know already, Q can be easily calculated. Now from here, so actually you don't get generally questions from this one. Only the formula they may ask. The formula they may ask the only formula. This formula they may ask in examination. Only this formula is important for you. You don't get any problems on this formula also. Nobody asks problems from this formula. Just simply remember the formula. You don't get the questions from this. Now this is important for us. Enthalpy change is very important for us. Okay, so already okay. We'll take in next class. Do you have class now? Do you have class now, beta?
At 11.
Shall I continue? 5 more minutes. Shall I continue?
Yes, sir.
So that I can complete this one. Enthalpy change we complete here. Only 2 slides are there. Remaining are simple slides only. They will come. This one we don't discuss about. Only this slide will take. Only enthalpy change we'll see here. Now, what is enthalpy change actually? Enthalpy change means, for example, I have taken a reaction where reactant is converting into product. Now, enthalpy of this reaction can be written like this: enthalpy of products minus enthalpy of reactants. What is the enthalpy of the product minus enthalpy of the reactant will give the enthalpy of reaction here actually. So here I have taken something like this. For example, I have taken a reaction like this. This is the enthalpy of some reaction, a small reaction it is. Now here the number of moles of oxygen 2 moles, the number of moles of water is 2 moles. Now what will be the formula beta here? Which formula we are taking here? So now enthalpy of products minus enthalpy of reactant is equal to enthalpy of reaction, correct? Now there are many number of products are there. So we have to take all the products. Now enthalpy of carbon dioxide plus 2 into enthalpy of water I have taken at the product side minus enthalpy of reactant. What are they? Methane is there, 2 moles of oxygen. Therefore enthalpy of methane plus enthalpy of what actually I have taken here? Oxygen. Taken what? Oxygen. So here you will get like this here. Now if I observe the formula here, let me see the formula now here. You see how many products we are having. Take all the products here, all the products including their number of moles also, all the reactants also you can take. All the reactants also you can take. Okay. In that case, sum of the enthalpies of the products. Sum of the enthalpies of products means all the products, including their number of moles. A means what? Number of moles of products. B means what? Number of moles of reactants. Minus sum of the enthalpies of reactant. And A, I, B are the stoichiometric coefficients of the products and reactants. You got this one, no? Observe here what happened. This one. This particular reaction we can write like this. Enthalpy change is very useful quantity to calculate the temperature depends upon the equilibrium constant. Delta H will be useful for calculating the equilibrium constant. K can be easily calculated. The following is correct, beta. Which formula is correct, beta? Which formula is correct?
First one, sir.
Right. Can you give the answer for this one? Negative, correct or not? Let me discuss next topic tomorrow class. I present 54 only. We'll take attendance better. Abhishek Sharma.
Present, sir.
Why? Aditya.
Present, sir.
Akriti.
Present, sir.
Anshu. Anuj absent. Anuj. Anushka.
Present, sir.
Apurva. Ashif. Adarva.
Present, sir.
Atul Rawat.
Present, sir.
Ayush.
Present, sir.
Bharati. Chaitanya.
Present, sir.
Present, sir.
Dhanshri.
Present, sir.
Deepta.
Present, sir.
Jnaneshwari. Gulabi.
Present, sir.
Kaushal.
Yes, sir.
Krunal.
Present, sir.
Much. Mayur.
Present, sir.
Ojas.
Present, sir.
Omkar M. Omkar C. Omkar M yesterday absent. Omkar M yesterday absent. Pradmesh.
Present, sir.
Pallavi.
Present, sir.
Samiksha.
Present, sir.
Raghav.
Present, sir.
Rahul.
Present, sir.
Raj. Ramya.
Present, sir.
Riya absent. Rohit.
Present, sir.
Sahil absent. Samruddhi.
Present, sir.
Puna. Shashi.
Present, sir.
Shashidhar.
Present, sir.
Srihari.
Present, sir.
Sneha Ji.
Present, sir.
Sneha VS.
Present, sir.
Sonali.
Present, sir.
Sumit.
Present, sir.
Sumit D. Suraj,
Present, sir.
Suraj, you.
Present, sir.
Triambak,
Present, sir.
Triambak, Triambak is there? Triambak absent. Umesh,
Present, sir.
Vaishnavi N,
Present, sir.
Vaishnavi J,
Present, sir.
Vaman,
Present, sir.
Vaman yesterday absent. Vedant,
Present, sir.
Vishal, yes.
Present, sir.
Swastika, Swastika absent. Tejaswini absent.
Present, sir.
Tejaswini is there. Swastika absent. Swastika absent. Just I am reading the absentee name beta. Swastika, Triambak, Sardak, Riya, and Anuj. These are the absentees. Right. You have any doubts, beta?